Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to cover uh, this surface tension factor affecting the surface tension, application of the surface tension, and surface energy. Okay. So these are the mainly topic where we will discuss and focus. Right. So let us discuss one by one. So what is surface tension actually? Okay. So before that, we need to discuss some of the term which is known as intermolecular terms. Okay. So this is your intermolecular force. What is intermolecular force? The force of attraction or repulsion between the two molecules. You know that every matters are made up of molecules, right? And if molecule it is made up of molecules, then there is definitely a intermolecular force between these two molecules. Okay. So there is a force either repulsive or attractive. So how many types of forces are there? See, first type is your cohesive force. Co means what? Same type. Co means what? Same type. So same type substance. The force between same type substance is known as cohesive force. For example, water molecules. The force between water molecules, force of attraction or repulsion between water molecules is known as cohesive force. Two drops of liquid coalescence into one with when brought mutual in contact. So let us take a two drops of liquid. So when you brought each other at same, so they will make it one. Why? Because they have force of attraction and they both are of same material. That's why I am talking about their forces between them is known as cohesive force. Okay, it is very difficult to break a mercury drop. So suppose there is a mercury drop. So if you want to break the drop, so what it will be very difficult because there is a very much large cohesive force, right? So I hope you have understood now cohesive force. Now let us discuss about adhesive. Adhesive, you know that mostly we want to stick any paper on the wall, so we use adhesive, right? Adhesive means what? Different material are responsible for force of attraction. It is not like that water, right? So if the force of attraction between the molecules of a different substance, then this type of force is called adhesive force, and the force enable us to write on the blackboard. So if you want to write on a blackboard, so what you are doing, you are using chalk. And when you are using chalk, then what will happen? When you are using chalk, then what will happen? So chalk will get stick. It means that chalk is different material and blackboard is of a different material, but still they get stick. And due to this adhesive force, because the chalk has different molecules, blackboard has different molecules, so the force of attraction between two different molecules are involved here. So this type of force are called adhesive force. Water weights the glass surface. So why water weights glass surface? So let us consider this is a glass surface, and if you take a water drop, so what will happen? So just you think water drop sticks. Why? Because due to adhesive force. If water molecules are attracted, so it means that there are cohesive force because it is of same material, right? But as we talk about the water as well as the surface, other surface, either glass surface or other any surface, so different surface. So it is that the force of attraction between different surfaces is known as adhesive force. So I hope you have understood now. Now, I am coming to the main topic. What is sur surface tension? Tension means what? Some stretching like this. It is the property of a liquid due to which its free surface have a minimum surface area and behaves as if they were in under tension and like a stretched elastic membrane, and this is called surface tension. So I will show you one GIF so that you can understand. See here. So this spider is walking on the water or any liquid surface. See how liquid surface appears to be like a stretchable body. So it means that there is a tension. When it come up, so it make it plane. So there is a tension between the liquid surface. So surface there is a tension. So due to tension, it behaves like elastic body. So this is known as surface tension, and it only happens at the surface of the liquid water only. Liquid water or any type of liquid are there. So this is known as surface tension. So try to define it in a proper way. Let us consider See here. Okay. Let us consider there is a liquid surface. Okay, and the surface tension at each and every molecules is acting parallelly. See here, suppose I am taking a small length L, then the force at which it is being attracted or it is acting for making a tension is in this direction. So whenever we define surface tension, so we will define it by surface force per unit length. So how much force is acting per unit length? Unit length means 1 meter length. Okay, unit. I am talking about unit length. And if you define surface tension, so its unit will be in Newton per meter. So surface tension can be defined as force per unit length. Force acting per unit length on any of the liquid body, and it should be on the surface only, because this is your surface phenomena. So again I am just reading this. It is a property of a liquid due to which its free surface tries to have a minimum surface area and behave as if we are under tension and like stage elastic membrane, and is called surface tension. And it is your scalar quantity. It is your not a vector quantity. It is your scalar quantity. Okay, it is your scalar quantity. And if you talk about dimension, so this dimension is your mlt minus 2. Dimension is your mlt minus 2. So this is the dimension, right? So I hope you have understood now what is surface tension. It is the tension on the surface and applied by the liquid. Example, rain. See here, one more thing is there. So raindrops are spherical in shape, and because each drop tends to acquire minimum surface area due to surface tension. So suppose there is a liquid. Okay, there is a liquid. So what happened here in liquid surface? What is happening? It is applying a tension. Here also it is applying a tension. So every surface they are applying a tension, and due to tension it will acquire a spherical surface. The more is the surface tension, the more spherical surface will be appeared. So this is the very much this is the example of a surface tension. Okay. Now one important thing. See here, needle, how needle is floating. See, you know that I have already told you that there is a surface tension. You can see here at surface there is a tension like this. There is a tension is being applied per unit length, and if you keep a needle so slowly without without making a hole, so it will start flow. Why it is flowing? Because there is a tension, and tension, due to tension it is not going downward. So it means that there is a force is being applied in this surface of the liquid, and due to this it is not going downward. So if you see the stakes, so suppose this is your needle, so needle weight is in downward direction and surface tension is acting in this direction. So force due to surface tension. So you can imagine that surface tension will act in this direction. Okay. Ultimately, if there is a weight, so surface tension will act in just a certain angle. So surface tension per unit length or force of due to surface tension is acting in this direction and in this direction. So I hope you have understood now how this is happening. Got it? Now try to derive some of the, before that derivation, so we will go for a discussion of a factor affecting the surface tension. What are the factors affecting the surface tension? First factor is your cohesive force. With the increase in a cohesive force, surface tension will increase. So surface tension is directly proportional to cohesive force. So for example, mercury has more cohesive force rather than blood. So that's why it has more surface tension, and due to more surface tension, what happens? It tends to become a sphere. Got it? Impurities. If there is an impurity, on dissolving ionic impurities, surface tension increase. The more is the impurities or ionic impurities, then it will increase the surface tension. Now if I will talk about the temperature, on increasing the temperature, what happens? Surface tension will decrease. Why so? Because cohesive force will decrease, right? So these are the thing. Now let us consider about the application of a surface tension. So oil and grease, spots on cloths can't remove. See here, when there is an oil and grease, spots on the cloth, so you can't remove it by pure water. So what you do, you add detergent are added so that it will increase surface tension, right? If you increase the impurities of ionic impurities, we are talking about ionic impurities. So when you dissolve a detergent, so what is happening here, ionic impurities are increasing. So due to these ionic impurities, so what will happen, surface tension will increase. And if surface tension of a water will which is ultimately get mixed, okay. So so that it will decrease the surface tension of, see here, there is a oil and grease, okay, oil and grease, okay. And when we increase the detergent in the water, so water's surface tension increases. And when it increases, and what happen, it mix with the oil to increase the surface tension, sorry, decrease the surface tension. And ultimately what will happen, it will come out of the this stain will come out of the shirt. Antiseptic, the most important thing, antiseptic, you know, antiseptic have a low value of surface tension, because if it will not have a low value, so it won't be able to spread, it will try to accumulate like ball like structure. So that's why antiseptic must have a lower value of surface tension. The surface tension of the all lubricating oil and paints are kept low. Why? Because if surface tension is low, so what will happen? It won't accumulate at one place. It will be spread easily. So that's why this spread over a large area. Now in soldering, addition of flux reduces surface tension. So if you know the process of soldering, where one wire is added with the another wire, and we use surface tension of molten and tin, and hence it spreads. So we use flux. Let us consider in soldering process what we use. We use tin. Suppose this is your soldering metal, and we use tin, and when we melt it, so what happen, it is not getting spread. So that's why we mix, what we mix flux. So flux is the material, when mixed with it, so it decreases the surface tension, and while decreasing the surface tension, it able to spread the properly. And when it is spread, so what will happen, it can easily go with each and every part, so that it can solder it properly, right? So these are the application of surface tension, okay. Now I hope you have understood this topic, right? Now coming to the next topic, that is your surface energy, okay. The energy at the surface, as we know that there is a tension, it means that it has energy. How we can say so confidently that there is an energy? So what is happening here, if you prick with the pin, so what will happen, surface drop will go down, right? See here, surface bubble will, or surface drop will go down. See, before that we try to understand what actually happening, which type of force is acting. See here, in this inside bubble, everywhere, every direction, the equal force are being acted, and due to this, what is happening, net force is zero, okay. Net force is zero. But when we talk about the drops at the surface, so see here, in this direction force is there, in this direction force is there, in this direction force is there, so and above there is no force, so it means that there is a net force, and that net force come under the surface tension only. But at the at inside the water, inside the depth, the D, so you don't find any net force, right? So what happened, these surface molecules will come down, and when it will come down, so what will happen, this bottom molecules will go up to fill this. So why this bottom molecules is going up, who is pushing this? It means that it has more energy. So what actually happens, surface has some energy, so when it come down, so it gives energy to these molecules, and these molecules get some that energy, and it will come to the surface. So the energy is being transferred. This type of energy which is going and coming down and going up, coming down and going up. This type of thing is known as surface energy. So to fill empty space, other molecules will rise, and the surface molecule has more energy than the bulk energy inside rock deep. So surface and molecules have always more energy. So that's why when it comes down, so down molecule will gain energy from this surface energy and it will go up. So this is what the every time this equilibrium things are happening. Now liquid surface tries to minimize the surface area to make stable, and this phenomena is called surface tension. See, they will always try, liquid surface will always try to minimize the surface tension. When it will minimize the surface, it minimize the surface area, so what will happen? Surface tension will become stable. So liquid surface behave like a stretch elastic. Okay, so liquid surface will behave like a stretch elastic, right? Stretch elastic. Now let us consider. Let us now consider there is a sliding. Okay, there is surface. This is your surface. Got it? We are talking about this is a surface. Which surface? Liquid surface, top surface. And I have made what? I have made one sliding wire. So wire has been attached with this liquid surface. Now tell me, since this liquid surface try to apply a surface tension inside it, so liquid surface will apply a force in this direction. So what will happen when we apply a force? So we have to do work. So after applying this force, so what will happen? Suppose earlier it has a distance of x, and when we apply a force and it is being displaced, right? So what is happening here? What is happening here? So when we are doing work, when we are applying a force and it gets displaced, it means that we are doing work. Okay. So work done on wire for sliding wire is equal to force into displacement. Now why we are applying, how much we are applying a force? How much we are applying force here? See, surface tension is, this is the force due to surface tension, and this is your external force, right? So can we tell that if we apply a force equal to surface tension, then we able to move or displace it slowly, right? So what is happening here? So external force is equal to surface tension. So can we tell this force as external force, and this is equal to surface tension? And what is the value of surface tension? Surface tension. So you know that surface tension is equal to force due to surface tension by per unit length. So finally we can write here force due to surface tension is equal to surface tension into length. So why don't we write here surface tension into length? Now you can say that, sir, why you are applying, why you are multiplying it by 2? So why we are applying by 2? Because if you are taking a liquid wire, so it has 2 layers. So this is the front view. So see here, 1 layer liquid surface and 2 layer. Okay, see here, it is just like imagine you are making a bubbles. Okay, so bubble has outside air as well as inside air. So how many layers are there? Outside layer as well as inside layer. So see, think about the similar bubbles layer. So in bubble layer, suppose this is your outside and this is your inside. So there are how many surface? 2 surface. So it means that 2 forces, 2 surface force, 2 surface tension force are acting here. So that's why we are multiplying how many force? 2 force. 2 surface force due to surface tension, and it should be multiplied by the displacement, so that we will able to get work done on the wire. So finally we have done work. Okay, so finally we have done work. So initial surface, let us see here, initial surface area. So let us consider this, that initial surface area was 2L into del x, and final surface area become 2L into x plus del x, because it has initial surface area as x into del x, x into L, because this is your L length. Got it? Now this is your final surface area. So change in surface area is how much? 2 see if you will multiply this and subtract final surface area minus initial surface area. Let us see here what is happening. So final surface area is your 2L x plus del x minus 2L del x, 2Lx. So see here 2Lx is common. So this will be how much? This will be 2L del x only. Okay. Right. See here. Just we calculate it. Calculate it. Let us calculate. 2L del 2L. Again. It is your 2. Let us see final surface area. So suppose their final surface area minus initial surface area. So surface area, right? Surface area. So final surface area is your 2L into x plus 2L into del x minus 2Lx. So 2Lx got cancelled out. Finally, you are getting 2L into del x. And if you are talking about the energy, so whatever work is done, that work is your stored energy. That work is the surface tension energy. So can we write here work done, that is work done is equal to energy, and this is equal to S, that is surface tension, into 2L into del x. See here, can we write here surface tension into 2L into del x, and this is your change in area. This is your change in area. So finally change in area, energy can be written as surface tension into change in area. Now we have written change in area is equal to surface tension into change in energy is equal to surface tension into change in area. So rate of change of energy per unit area is known as surface tension. So conclusion, change in surface energy per unit area is called surface tension. So if you want to find the surface tension, ST is equal to change in surface energy per unit area, right? So this is the final formula. Got it? So I hope you have understood surface energy. So we have discussed surface energy, we have discussed some basic application, we have discussed about factor affecting the surface tension, how it is working, how it is being plotted, and these are the thing, what is actually surface tension, what is adhesive, what is cohesive. So these are the basic. So I will discuss more application like capillarities and all, so in the next video session. So for this basic chapter it is okay for now. So you have learned surface tension as well as surface energy. So I hope you have understood well, and if you have any query, please ask me directly in the comment section. And you can also wait, or you can also subscribe our channel so that you can get our video which is similar, right? I will also make more and more video in depth, as well as now I'm announcing to that I'm also going to make a numericals special video. So if you want to get regular videos, so please subscribe our channel. Thank you.